Welcome back, everybody. AP Chemistry. We're still in Unit 4, Section 3, and I have just two problems to take a look at with you. We left off talking about balancing equations and oxidation, but let's take a look at balancing things not in an acid situation, but with a basic situation. Okay, so it's basic solutions, and it'll always tell you that we're in a basic solution, so that'll be okay. Notice that we start everything the exact same way we did before, but now we're going to be adding in hydroxides to eliminate any hydrogen ions that might be present. Okay, so the equation that we'd see given this example would be zinc with nitrate in there. It's going to make nitrogen dioxide and the zinc ion. Okay, so step one is always going to be exactly the same as everything else. We see our charges. That's a 0. That's a +2. There's a -2 always. We see that. So I see a 6, but I need to remain there. So that's a 5. And this ends up being a +4. So what does that tell us? That tells us that we have a reduction with our, in this case, we have our reduction with our nitrate. It's going from an NO3 -1. Remember, that was going to be our +5, and it's going to become the nitrogen dioxide. That's going to be our -4. Now, the oxidizing part, that's going to be our zinc. And remember, the zinc went from a 0 charge, because it's an element by itself, to a zinc with a +2 charge. Okay, now I know those pieces are in there. Let's take a look at step 3. I need to balance my elements. Nitrogen, nitrogen, zinc, zinc, that's done. Now I need to balance my oxygens. I balance my oxygens by adding water. So I have 3 on this side, I have 2 on this side. I need to add 1 water to this. Okay, now I take a look and I'm going to balance my hydrogens. Okay, I see I have 2 hydrogens here, so I'm going to need 2 hydrogens then on this side, 2 hydrogen ions. Now I go through, there's nothing that I have to do down below with that. Now I have to take a look and add my electrons. Okay, so here I have a +2 and a -1. Over here I have nothing. So a +2 and a -1, I need to add 1 more electron here, don't I? I have a 0 and I have a +2, so I need 2 electrons here. Now let's go ahead and balance or equalize the electrons. I have 2 electrons on this side, so that means I have to double everything on this side. All right, so let's rewrite everything, and then we can see what we're dealing with. I have within all of this, I have 2 electrons plus 4 hydrogen ions plus 2 nitrates plus my zinc. I'm going to get 2 nitrates. I'm going to get two waters. I have my zinc ion and my 2 electrons. Okay, I can get rid of my electrons right away because they're both on the same side. Now I have to add hydroxides to eliminate my hydrogen ions. Okay, so that's going to be key. I need to add my hydroxides to balance out. So I have 4 hydrogen ions, so I'm going to add 4 hydroxides. Okay, I can do that right where I had this. So what does that give me? That gives me 4 waters. Okay, I have 4 waters now. I have 2 nitrates. I have a zinc. I'm going to get, let me get rid of that so it's a little bit neater. I'm going to get 2 nitrates. I'm going to get 2 waters and my zinc ion. Notice on this side I have 2 waters. I have 2 waters. Okay. So in all of this, what's my final balanced equation? 2 waters plus 2 nitrates plus my zinc metal. That's going to give me 2 nitrogen dioxides and a zinc ion. Pretty straightforward. These aren't too bad. Okay, that's finishing out that one. All right. Last piece, I'm going to take a look at something a little bit simpler. We don't have to include all those things. In previous problems, we've been adding in all of those ions in there. We added in so they become a stable element. Let's take a look at a net ionic equation within a redox situation. Okay, so net ionics, we're going to follow the exact same pattern with them. Let's balance it as a net ionic, though, which means that we're going to end up with an ion at the end. So this is a -2, -2, -2. That makes this a +4. Now, this one gets a little bit tricky because we've got a whole bunch of stuff going on in here. Just to speed things up, we have a negative 14, but I have an overall, so I have to get to a negative 12. And so this ends up being a plus 5, sorry, a plus 8. So 16, 14, that'll give me an overall negative 2 with that. This goes from a negative 2, here's my chromium, that's a plus 3, that's a plus 4. I think we got everything taken care of here. Okay, so now balancing out the redox. Okay, so the reduction, the thing that's going to be reduced in all of this, my Cr2O7, negative 2. That chromium will go down to a plus 3. Okay, and what's getting oxidized in this case is going to be my C2H5OH. I'm focusing on the carbon there. That's going to go down to a carbon dioxide with a plus 4. Okay, so you see in there, the negative 2 comes down to a plus 4. All right, so let's balance the elements. I have 2 chromiums here. I have 2 chromiums here. 2 carbons, 2 carbons. Everything else is oxygens and hydrogens in there. So let's balance out my oxygens. Okay, so I have 7 oxygens over here. That means I'm going to have 7 waters here. I have on this side 1 oxygen. On this side I have 4 oxygens. Okay, so what that means is I need to have 3 waters. Okay, so now my oxygens are balanced. Let's go out and balance my hydrogens. I have 14 hydrogens on this side, so that means I'm going to have to add 14 hydrogen ions on this side. Down here I have 6 plus another 6 hydrogens. Don't forget about that. So that means I have 12 hydrogens to account for on this side. Okay, so now all of those are taken care of. Now let's take a look at charges. On this side, I have 14 minus 2. Okay, so that gives me a minus 12. And on this side, I have a plus 3. Okay, so balancing all those things out, I need to add in here, let's see, 6 electrons. Okay, and because the plus 3 times 2 is plus 6, and so now my electrons are balanced there. I see on this side I have 0, on this side I have 12. So I need to have 12 electrons on this side. Okay, now we balance our electrons. I have 6 electrons and 12 electrons. So I'm going to have to multiply everything by 2. All right, so let's rewrite this whole mess. Let's see what we've got. I have 12 electrons up here, 2 times 6, 2 times 14. Okay, that gives me 28 hydrogens. 28 hydrogens. Let's see, I have 2 of my Cr2O7, negative 2s, dichromates. I have, don't forget about down below, I have 3 waters. I have my C2H5OH. Now let's take a look at my products. I have 4 chromium ions. I have 14 waters here. Looking at the products, I have 2 carbon dioxides. I have 12 hydrogen ions, and I have 12 electrons. Okay, so we got all that taken care of, and let's see what we can do now. We can cancel out some electrons, can't we? I have 12 electrons, 12 electrons. I have 12 hydrogen ions here, and on this side I had 28, so minus 12. Now I have 16 total hydrogen ions here. Okay, then if I rewrite everything, it looks like I'm done. I have 3 waters here. Oh, my 3 waters and 14 waters on this side. So I can cancel out 3 of those. That gives me 11. So I can say that I'm done on the reactant side of things after I've got my C2H5OH taken care of. I have 4 chromium ions and 11 waters and 2 carbon dioxides. We can leave these in the ion form because it is asking for a net ionic equation. Guess what, guys? We are done. Congratulations, done with redox reactions in section 3. That should bring you through everything else. And we have only one other component with this whole thing, and that's going to be getting into acid and base. So that's not too bad. Good luck.